On the Pacific coast of the Soviet Union, far from major cities and public attention, lay Chazhma Bay. It was not a commercial port and not a civilian harbor. The bay served as part of a restricted naval zone connected to facilities near Bolshoi Common. Access was limited, movement was controlled. Most activities that took place there were not discussed outside official channels. By the mid-1980s, the Soviet Navy operated a large fleet of nuclear-powered submarines. These vessels required regular maintenance, including periodic replacement of nuclear fuel inside their reactors. The work was technical and precise, carried out by trained specialists under strict procedures. In August 1985, one such submarine was undergoing scheduled maintenance at a dock in Chazhma Bay. The task at hand was routine by naval standards, refueling the reactor. This process involved removing the reactor lid, handling nuclear fuel assemblies, and reinstalling components with exact alignment and measured positioning. There was little room for error. Unlike conventional engines, a nuclear reactor does not rely on combustion. Its power comes from a controlled chain reaction. That reaction remains stable only when fuel elements, control rods, and structural components are positioned within very narrow tolerances. Even small deviations can change the balance inside the reactor core. Refueling operations required coordination between technicians, engineers, and naval officers. Equipment had to function correctly. Measurements had to be exact. Each step followed written procedures developed over years of fleet operation. The setting itself did not suggest danger. Chazhma Bay appeared calm and ordinary on the surface. Submarines were moored along piers. Service vessels moved slowly across the water. Cranes and maintenance crews operated as they had many times before. For those working there, the environment was familiar. The submarine undergoing maintenance had already served in the fleet. Its reactor had operated before, and the refueling process was considered standard. There were no public warnings, no external signs of instability. Work progressed according to plan. But nuclear systems depend not only on procedure, but on precision. During the refueling operation, an alignment issue developed while handling the reactor lid assembly. Adjustments were made. Equipment was repositioned. In ordinary industrial contexts, such adjustments would be routine. Inside a nuclear reactor, they carried different weight. What followed did not resemble an explosion in the conventional sense. There was no detonation like a weapon. There was no visible mushroom cloud. Instead, there was a sudden, uncontrolled release of energy, a brief critical event inside the reactor core. The moment was short. Its effects were immediate. The accident at Chazhma Bay did not begin as a dramatic failure. It began as a technical deviation during a maintenance procedure in a place where routine and restriction shaped daily life. Only afterward did it become clear how quickly a controlled system could cross a threshold and how little time there was to correct it once that threshold had been passed. The refueling operation at Chazhma Bay was already underway when the deviation occurred. The reactor lid assembly had been lifted as part of the fuel replacement process. According to later accounts, the lid was raised higher than procedures allowed. In a nuclear reactor, height is not just a mechanical measurement. It affects the geometry of the core, and geometry determines whether a chain reaction remains controlled. As the lid assembly moved, control elements inside the reactor shifted beyond safe limits. For a brief moment, the reactor configuration entered a critical state, meaning the nuclear chain reaction intensified instead of remaining stable. There was no countdown, no warning siren. Witnesses later described a sudden flash and a powerful upward force. The energy release was rapid, localized, and violent. It was not a nuclear explosion in the sense of a weapon, but it was a criticality accident, a burst of uncontrolled nuclear fission inside the core. The reactor lid was blown upward. Structures around the compartment were damaged. Personnel closest to the reactor were exposed instantly. 10 specialists working directly above or near the reactor were killed almost immediately. The force of the explosion and the intense radiation left no time for response. Others in the vicinity were injured by debris or radiation exposure. The explosion did not propagate beyond the submarine in a chain reaction. It was contained within the reactor compartment and nearby dock structures. There was no secondary nuclear detonation. However, radioactive material was released into the surrounding area. A visible cloud formed above the dock. It rose briefly and then dispersed with the wind across part of the naval facility. The scale was limited compared to later nuclear disasters, but within the confined military harbor, the contamination was significant. Personnel in adjacent areas initially did not understand what had occurred. Some reported feeling a pressure wave. Others noticed dust and fragments falling around the pier. Only after radiation alarms activated did the severity become clear. Emergency response began quickly. Naval units secured the area. Fire crews and technical teams attempted to assess damage and prevent further release. Radiation monitoring devices were deployed across the dock and nearby vessels. The priority was to stabilize the site and limit spread. The submarine itself was heavily damaged in the reactor section. Structural integrity was compromised, and radioactive contamination made immediate access hazardous. Specialized teams were required to evaluate conditions inside the compartment. Beyond the dock, life in the surrounding region continued without immediate awareness. The location was restricted, and information did not leave the naval perimeter. Within hours, however, the internal classification of the event changed. What had begun as a maintenance procedure was now categorized as a serious nuclear accident. The critical moment had lasted only seconds. Its consequences would extend far longer. In the silence that followed the explosion, two realities became clear. First, the immediate human cost had already been determined. Second, the response to what happened would remain contained not only geographically, but informationally. The accident in Chazhma Bay was now a closed military matter, managed internally, recorded in classified reports, and shielded from public view. In the hours following the explosion at Chazhma Bay, the priority shifted from understanding what had happened to preventing further spread of contamination. The naval base was immediately sealed, access routes were restricted, and movement within the harbor was tightly controlled. Radiation monitoring teams began surveying the dock, surrounding vessels and nearby shoreline. Measurements confirmed elevated levels in the immediate area of the damaged submarine. The contamination pattern was uneven, shaped by wind direction at the time of the explosion and by debris dispersed during the blast. Specialized military units trained in radiological response were brought in. Their tasks included decontaminating surfaces, removing radioactive fragments, and isolating affected structures. Protective suits, respirators, and dosimeters became standard equipment for anyone entering the zone. The submarine itself remained the central challenge. Its reactor compartment had been severely damaged. Structural components were displaced, and radioactive material was present both inside and around the vessel. Access required careful planning. Teams worked in controlled rotations to limit individual exposure times. The cleanup was methodical rather than dramatic. Sections were washed down, contaminated materials were collected and sealed, radiation levels were recorded repeatedly. Meanwhile, those who had been exposed were transported to military medical facilities. Acute radiation symptoms appeared in several individuals within days. Treatment protocols were applied according to the knowledge and resources available at the time. Some required long-term observation. Official casualty numbers were limited and precise. 10 fatalities were acknowledged internally. Dozens of others were listed as injured or exposed. Outside the naval perimeter, public awareness remained minimal. Chazhma Bay was part of a restricted defense complex. Civilian authorities in nearby Bolshoi Common were informed only to the extent necessary. There were no public evacuation announcements and no press coverage. Information moved upward through military channels rather than outward toward society. Reports were compiled, classified, and distributed within the Ministry of Defense. The language used was technical and controlled. The event was described as a criticality accident during refueling operations. Causes were analyzed in procedural terms: equipment handling, deviation from protocol, mechanical alignment. Responsibility was assigned administratively. Investigations focused on compliance with established safety rules. The broader implications were not discussed publicly. Environmental impact assessments were conducted within the military framework. Contamination was determined to be localized primarily within the harbor zone. Over time, radiation levels decreased as decontamination progressed, and natural dispersion reduced concentration. For the surrounding population, daily life continued without formal acknowledgement of what had occurred nearby. The secrecy was not unusual for military incidents involving nuclear technology. In 1985, such matters were considered strategic and confidential. Within the naval community, however, the accident was remembered differently. It reinforced the risks inherent in maintaining a fleet powered by nuclear reactors. It also highlighted how a deviation lasting seconds could carry irreversible consequences. The visible signs of the explosion were eventually removed. The dock resumed operations. The damaged submarine was handled according to long-term disposal procedures. Officially, the situation was stabilized, but like many military nuclear accidents of the period, the event in Chazhma Bay remained largely outside public history, documented in archives, known within specialized circles, and rarely discussed beyond them. In the months that followed the accident at Chazhma Bay, operational routines gradually returned to the naval base. Decontamination work continued until radiation measurements reached levels considered acceptable for controlled military use. Sections of the dock were repaired, equipment was replaced. The visible damage faded. The submarine involved in the explosion did not return to service. Its reactor compartment had been irreversibly compromised. Decisions regarding its handling were made within naval command structures, following procedures designed for damaged nuclear vessels. Over time, it became part of the broader inventory of decommissioned submarines awaiting dismantlement. For personnel within the fleet, the accident prompted procedural revisions. Refueling operations were reviewed in detail. Additional safeguards were emphasized, and stricter alignment controls were introduced. Training protocols were adjusted to reduce the risk of similar criticality incidents during maintenance. These changes were not presented publicly as consequences of a specific failure. They were incorporated quietly into operational standards. At the national level, the accident occurred during a period when information about nuclear safety was tightly managed. In 1985, military nuclear incidents were not discussed openly, even within civilian administrative circles. The public narrative surrounding nuclear technology remained focused on strategic capability rather than operational risk. Only a year later, the disaster at Chernobyl nuclear power plant would shift the global conversation about nuclear safety. Compared to that event, Chazhma Bay was smaller in scale and more geographically contained. Yet it preceded Chernobyl and reflected similar vulnerabilities: human error, procedural deviation, and the limits of complex systems under pressure. The difference lay in visibility. Chernobyl became international news. Chazhma remained largely internal. For those who served in the Pacific Fleet, however, the memory did not disappear. It circulated through professional discussions and personal accounts. Within naval circles, the name of the bay carried a specific meaning, a reminder of how quickly routine operations could change. Environmental assessments conducted over time indicated that the contamination remained localized. The surrounding region did not experience large-scale, long-term exclusion zones. Civilian life in nearby Bolshoi Common continued without the public disruption seen in other nuclear events. Still, the accident belonged to a broader pattern of Cold War-era nuclear incidents. Many of them classified, many resolved without public explanation. Together, they formed a parallel history of nuclear technology, one that existed alongside official narratives of progress and deterrence. The legacy of Chazhma Bay is therefore measured less in headlines and more in documentation. It contributed to changes in naval safety practice. It underscored the fragility of precision-dependent systems, and it demonstrated that even in controlled environments, the boundary between routine and catastrophe can be thin. The explosion itself lasted only seconds. The response lasted months. The silence lasted years. Today, the accident stands as a reminder of a period when nuclear technology was both essential and opaque, managed by institutions that prioritized containment not only of radiation, but of information. Chazhma Bay returned to quiet waters, but within the archives of the fleet, August 1985 remains recorded as a moment when maintenance became tragedy and a controlled system briefly lost control.